In this project, I'm going to be working on an Arduino compatible interface for the Vex robotics components. I currently have a number of Vex robots, and we're using the PIC controller from Vex. And those have gone old, and I'm looking at replacing those, but I don't want to go with the Vex Cortex. Very good platform. It works well. The main thing is cost. The second thing is that students can't necessarily take them with them, do them at home. There's the issue also of software. Software is not free, so even if the students take it, they can download the trial version, last them for 30 days. So I'm looking for a compromise in cost because the Cortex is $250 plus the software plus other things. So I'm looking for an Arduino compatible solution. There are some out there already. I'm looking at using the Arduino Mega 2560 for a number of reasons. It has more interrupts. I want to use those interrupts for the encoders. It also has more serial ports, although I don't think that's going to be critical for the Vex. It obviously has more I/O. It has more memory, so those elements are to my benefit as well. So I'm looking at using then that Mega 2560. I also looked, in order to make my connections to the Vex, I was looking at a number of Shield's prototype boards that I may use, and I was looking at the one from DFR Robotics, or DF Robotics. And I initially started, as you can see, prototyping it up. These are going to be for my motors and sensors and other kinds of connections. Started soldering it up and everything, and I moved away from this as my solution for a couple reasons. First of all, the board, let me go in this direction, is slightly longer than the Mega. Not a big deal. It simply would make my job of making a case for this a little bit easier. Also, it didn't have as much flexibility as I wanted in the layout. There were a number of buses already soldered on there. There were a number of different connections and connectors given. It just didn't seem to be the perfect match for me, so I looked at some other options. What I ended up going with is this one. It's an exact same shape and size as the Mega 2560. It does have some things that are connected, and they're not quite as obviously shown here because of the way the board's manufactured, but there are some connections that are common. But I have a bigger pattern of holes that I can make use of. So that's going to work out quite well for me. So I'm going to be using this on top of my Mega, make my connectors and connections onto this board, power connections as well, maybe some switches and LEDs for indicators. And then I'll build a case that'll go around this and support this to make it a little bit more protected, also to support the connectors when they're in here so that they're a little bit less likely to fall out and provide a little bit more security there. With this kind of solution then, it's going to be a little bit less expensive, obviously a little bit more work on my part to create these. But now this is simply going to be using the Arduino software for them to program. And that's the other thing too that I was looking at as a consideration in doing this project. As I mentioned, cost was one, the cost of the software was one, but also now the students will have to work at a higher level of programming. And I've seen that as students have been working with robotics over the years, they come in with a set of skills that's higher than previous students. Their programming ability is at a higher level. So I want, and I can do that with this, I can take them and start off from the very beginning with some more complex things, rather than have libraries like with the Vex, where to make a motor come on, they've already got a library to do that. To read values from the encoder, there's already a library to do that. So this gives me a lot more flexibility in the skill level of the student that's using it. I can make it very simple, create my own libraries, or I could make it very sophisticated and have the students do that. So it gives me a wide range of options. So stay tuned. I'll be posting updates as I create this and create my case for this, and I'll share you my videos and along with my progress. Okay, thank you.